A man self-conscious about his weight brings a scale on vacation with him. He stays in a hotel and is searching for an ice machine so he can preserve the food for his family. He is curious on how much he will weigh in an elevator. He weighs an initial 70,000 grams as he steps onto the scale in the elevator. What will the scale read if the elevator has an acceleration of 3.5 meters per second squared? After choosing the wrong floor, the man realizes he needs to go down a couple floors. What will the man weigh after the elevator excels at negative 0.5 meters per second squared? He gets the ice and pushes a button to go back up to his room as the cable snaps. What will the man weigh while in free fall? The equation being used comes from Newton's second law, the sum of all forces, which is mass times acceleration. The two forces acting on the man are normal force and gravitational force. Gravitational force being the attraction between any two objects with mass. The equation is mass times gravity. Normal force is the restoring force, the force that stops an object from falling through a surface with a perpendicular direction out from the surface. The equation of gravitational force is negative in the equation because on Earth there is a negative acceleration of negative 9.8 meters per second squared as gravity pulls you downwards towards the ground. But a man cannot have a negative mass, so to avoid that you need to add over gravitational force to solve for normal force. So you're adding this one over to the other side, over here. To find the weight of this man, you need to solve for normal force, Newton's third law. When an object applies a force on a second object, the second object applies an equal force back, which in this case is normal force. The man is applying the force to the scale, meaning the elevator is pushing the same amount back to prevent the man from falling through the elevator floor. Finding this normal force will therefore tell us how much the man is pushing down on his weight, or his weight. After the elevator excels in an upwards direction at 3.5 meters per second squared, the floor has to push up on the standing man with a greater force than the initial weigh-in. This gives the man a higher final weight. As the man realizes he has to go down a couple floors and the elevator descends at negative 0.5 meters per second squared, there is a negative acceleration because the elevator is moving downwards. The ground does not have to push the man anymore, giving the man a final weight less than his initial. The man has no weight as he is in free fall because, again, you need to solve for normal force. Adding gravitational force to the other side. Earth's acceleration in normal force is negative 9.8 meters per second squared. After adding them together, you get a weight of 0 newtons, less than his initial weighing.